here's the next question, number 22. A buck converter, as shown in the figure below, is working in steady state. The output voltage and the inductor current can be assumed to be ripple-free. Now the next figure shows the inductor voltage VL during a complete switching interval. Assuming all devices are ideal, find the duty cycle of the buck converter. Okay, so this is not a multiple choice question, so we will have to work it out. Now the first figure gives us the circuit for buck converter. And note the three different voltages over here. We have VG, the source voltage, VL, the voltage across the inductor, and V0 at the end. And this figure over here, the second figure, shows a waveform which gives us the inductor voltage VL during a complete switching interval, which means when the converter is on and when it is off. You will notice that the voltage range is from 30 volts to minus 20 volts. So we will have to keep that in mind while solving this. So let's start with the first part. We'll work on the figure over here given, the waveform given here. During the on period, let's write one equation, and during off period, we write another. So corresponding to the figure over here, let's write an equation during the on period. Now during the on period, the circuit is working. Just a simple explanation there. The circuit works during the on period. So during T on. Okay, let's write the KVL equation over here. So we have VG minus VL minus V0 is equal to 0. Quite a straightforward equation. Now, let's write this in terms of VL. Now, VL in terms of the rest, in fact. So we'll take everything else on the other side. So we have VL is equal to VG minus V0. Now we know from this waveform over here that VL during T on is 30. So this is 30 volts. So this is our first equation. VG minus V0 is equal to 30 volts. Let's call that number 1. Now the second equation is during the period of T off. Okay. Now during T off, what is off? That is what you'll have to just think. In simple terms, the source is off. So VG is 0. So we use the same equation here. So VL would be equal to 0 minus V0. So that gives us VL is equal to minus V0. Right? Okay. So this part during T off, VL is minus 20. And this further implies that minus V0 is equal to minus 20. And that gives us that V0 is equal to 20. So we can use V0 here and find out what is the value of VG using this equation over here. So VG minus V0 is 30. V0 is 20. So what will VG be? Let me just get another paper here. Okay. So the equation is VG minus V0 is equal to 30. We know that V0 is 20 now. So that tells us that VG is equal to 50 volts. Now because the question asks us about the duty cycle, here is a standard equation. V0 is equal to alpha VG. Okay. Output voltage is equal to the product of the duty cycle times the source voltage. So this is the duty cycle. This is what we need to find. So we know what is the output voltage and we know what is VG. VG is 50 and V0 is 20. So that's 20 is equal to alpha times 50. Alpha equals 20 by 50, which gives us 2 by 5, and that's 0.4. So the final answer here is 0.4. Well, I hope this has helped. See you in the next video.